My recently finished project was to convert old 1970s flashgun to stereo microphone for my camera, but also for office use with digital voice recorders. The flashgun was top of the range in its time, Cobra 30TD, now completely obsolete and worthless. Camcorders have built-in good quality microphones, but due to being in the same case with zoom and focus motors and operator controls, they pick up unwanted equipment noises. I can hear zoom and focus noise very clearly in videos shot with my Canon. This is the main reason to invest in microphone mounted separately for video recordings. I decided to buy two Panasonic WM54 electret capsules and mount them inside old flashgun head. The flashgun is easy to attach to all camera and tripod mounts, as well as it has ability to point mic into the desired direction. I could also reuse the flashgun battery compartment, holding 4 AA batteries, 6 volts in total, to power the electret capsules and mic preamplifier. Result so far is partially satisfying. The idea of having a mic in the flashgun case works well. Easy to mount on the camera, isolates the camera noise well, easy to attach to tripods in various other locations, including on my desk. The sound quality, however, is average. Not bad, but I was expecting better. Anyway, I need to test it for some time to decide what to do with it next.
So the idea is relatively simple. We have 2 capsules. So let's say this is capsule 1 and this is capsule 2. Both are Panasonic WM54. These capsules obviously are connected to ground. On one side. On the other side, they need to be connected to the positive power supply, because that's how was the requirement from the of the electret microphone. And there needs to be a resistor. So that's the plus, that's the minus, and the resistors are 4.7 kilo ohms. So 4.7 kilo ohms, and both resistors are connected to the battery. That is 6 volt, and obviously the other connector of the battery compartment goes to the ground. And then we need an output. So actually I have 2 outputs from the microphone. One, if we assume that this is left, this is right, goes through the capacitor into the stereo plug, and that's basically 1 microfarad capacitor here. But we also have outputs here, and there is also I haven't sort of put a switch here. There is a switch, and if I cut off the power supply to the capsules, then I can use plug in power, like Sony camcorders or Canon camcorders or some other equipment, Olympus voice recorders. All these devices have or are able to provide power to the electrode capsules. So I have a choice. I can either put power and then use the signal from the electrode microphones that are internally that have internal power supplies from the 6-volt battery, or I literally connect electrode mic capsules to the equipment that is able to provide power and then decouple DC. The battery is also connected to the circuit that is able to tell what's the voltage of the battery. And I wanted to have a warning when the 6 volts drops to 4 volts. So that for me would be the indication to change the batteries. If we have here the positive terminal, here let's say we have negative terminal, we have a Zener diode. In my case it was 4.9 volts Zener. And then we have to have a resistor that limits current flow through the Zener diode. And then this provides a voltage to the transistor. And here is LED together with current limiting resistor, and this LED will illuminate if the voltage is above 4 volts. And then we have another transistor that does illuminate when the voltage drops below 4 volts. So here it is, that's the whole circuit. So that's the green LED, that's the red LED. So that will light when there is more than 4 volts. In my case, this lights, or to be precise, 3.7 volts, and that is when it's below 4 volts. This is 10k, this is 10k, this is 10k. In my case, this is 460 ohms, and this is 460 ohms. And that's basically the circuit that I have to check the battery to give me the idea about the battery voltage. And essentially, these two circuits sit inside the flash gun. So this is conversion of the old flash gun from the 1970s to the stereo microphone. The capsules are inside already. There is a little bit of a copper net screening visible. This is the separation between the stereo channels, left and right, or yeah, it's going to be like that. So this is left, this is right, and then there is a support for the windshield that will go on top. This is the cable, and I can adjust this basically any way I want, exactly like the flash gun was supposed to go. I can also extend that and make it more unidirectional. The cable for the flash gun was inside the hinge here, but this shielded cable that connects capsules with the output here, with the socket, was the space here is quite small, so my worry is this cable was going to be damaged very easily by rotating the head. So that's why it's externally connected to the bottom part. This is reused flash gun controls. I removed all the previous labels and labeled it my way. So basically this is on and off for the power for the electrode capsules. 6 volts. Batteries are still inside here in the battery compartment, and here I can choose between powering the capsules, the electric capsule microphones with internal battery, or use plug-in power if there is plug-in power available from the device. I connect it to so many cameras, and some voice recorders have power output through the socket, and provide some power for the electric microphones. Here is battery tester. This is actually not used, this one, and the battery tester, when I push it, it shows whether batteries are more than 3.7 volts, and if then the green light is on. When it's less than 4 volts, this red light will illuminate. So for the bit somewhere between 3.7 and 4 volts, both are illuminated. More than 4 volts, only this one is illuminated. Less than 3.7 volts, only this one is illuminated, and that gives me an idea about the condition of the batteries inside. I thought that probably 2/3 of the fresh battery voltage, which is 6 volt, is okay to know about. And then what I'm planning to do now is to have this headphone amplifier, which is essentially a operational amplifier with some additional circuitry to be fitted here in the base, and that will allow me to increase the level of the signal from around 10 to 100 microvolts at the moment to more line input. So this is the original base of the flash gun, and then it's going to sit here in the base and will provide some additional additional amplification of the signal if that's required, with a separate output. So I can choose between the output directly from the capsules and the output from the amplifier, and also the switch is I can switch it on and off with this volume control here. So what I need to do, I need to open this now and provide power from the batteries, 6 volts that need to go into this board, and then obviously signal from the capsules to the input of this board, and then put it all together, and that's going to be end of this microphone project. This is going to be used on my camera. It's quite bulky, but that's on purpose to avoid any noises from the camera motors or from the operator, so like handling the camera transmitted into the microphones. So I think by having this distance here, this is well isolated. That's what I hope. There's also sort of like isolation inside the head. There is some foam behind the capsules, and the capsules are suspended using the silicone. Yes, so that's for the cameras, but also with a stand it's going to be my desk microphone. I'm going to use it with a voice recorder for a little bit of a project that I have later. So let's open this, and I'm going to get wires from the capsules and the batteries into this board, and then we put everything together. So here you can see all the electronics. This is where the signal from the capsules, from the both capsules, are coming in, and then goes into this board. This board contains 2 resistors that provide power for the electret microphones, and also 2 capacitors that filter DC, that then the signal is going into the output socket. And this board here with the two transistors and a diode and some resistors is the circuit that checks the condition of the batteries. Batteries obviously are here, and now what I need to do, I need to wire the signal from the microphone, from the capsules, to go into this board, and also power from here, from the batteries, to go into the board. So that's what I'm going to do right now. So the amplifier board is soldered to the wires that are connected to the electric microphones and the power supply. And all I need to do is to close the base. So I'm going to put this into position, and now the important bit is to get okay. And there is one more thing that I need to fit, because this base is too wide for some of the camcorders to accept it. There's also no tripod mount here in the base. I need to add this adapter to the base, and now it is, the microphone is fully done. All I need to do is to test it. I need to also find some nice knob. ABS, a system usually electronically controlled that senses incipient wheel lockup during braking and relieves hydraulic pressure at wheels that are about to skid. Going to increase the volume to maximum. ABS, anti-lock brake system, a system usually electronically controlled that senses incipient wheel lockup during braking and relieves hydraulic pressure at wheels that are about to skid. ABS, anti-lock brake system, a system usually electronically controlled that senses incipient wheel lockup during braking and relieves hydraulic pressure at wheels that are about to skid.